Welcome to Cosmic Compass, where we journey together through the mysteries of the universe. From distant galaxies to the smallest particles of life, we explore the science that shapes our cosmic story. Today, let's dive into a question that connects both biology and space. Can viruses survive beyond Earth? And what does that mean for the future of exploration? Viruses are among the strangest things we've ever studied. They don't quite fit into our definition of life. They aren't alive in the usual sense, but they aren't completely non-living either. Their only apparent purpose seems to be reproduction, hijacking the machinery of living cells to make countless copies of themselves. A virus is nothing more than a strand of DNA or RNA wrapped inside a protective protein coat, hundreds of times smaller than bacteria. And yet, despite their simplicity, viruses are everywhere. They outnumber every other form of life on Earth by nearly 10 to 1. Every cell-based organism we know of, from the smallest microbe to us humans, can be infected. But here's a question worth asking. What happens to viruses beyond Earth? Could they survive the harsh environment of space? If a spacecraft carrying human explorers or robotic probes were to land on another world, could we unintentionally bring viruses or bacteria with us? And what about the astronauts themselves? In space, the human body is stressed in unusual ways. Does this change the way diseases behave? Finally, could there ever be a war of the world scenario where alien microbes infect us, hosts with no natural immunity? Let's explore these questions one by one. First, let's consider whether microbes from Earth can hitch a ride to other worlds. This process is known as forward contamination, and it's something space agencies take very seriously. When a spacecraft is being built, it is often assembled inside a clean room. At first glance, this is to protect sensitive instruments from dust, but just as importantly, it's to keep out Earth's microbes. For satellites destined to remain in Earth's orbit, contamination isn't much of a concern. Eventually, those satellites will fall back and burn up in the atmosphere, but probes travelling to distant destinations, Mars, Europa, Titan, face much stricter sterilisation. Every component is carefully wiped with alcohol. Then, if possible, the probe is baked at up to 120 degrees Celsius for 30 hours. Of course, some instruments are too delicate for such treatment, so alternative sterilisation methods are used. The goal is not absolute perfection, because eliminating every single microbe is nearly impossible, but rather to reduce the count of bacterial spores to fewer than 300,000. Why so careful? Because some bacteria, known as polyextremophiles, are incredibly resilient. They can survive heat radiation and vacuum. Some of them may endure even after sterilisation. Once launched, these hardy survivors face new challenges: intense ultraviolet radiation, extreme cold, and the emptiness of space. Yet, if even a few survive the journey and land on a world with the right conditions, they could, at least in theory, begin reproducing. What about viruses outside of a host? They don't remain viable for long. Most collapse within days, even under favourable conditions. In space, their survival time shrinks even further. Unless they are sheltered within a living host, viruses are unlikely to survive long enough to pose a threat. So could Earth have already seeded other planets? With life scientists estimate the chance is extremely low, about 0.01%. But low is not zero. On robotic spacecraft, viruses don't last long. But things change dramatically when we talk about human missions. Humans bring their own environment with them: pressurized cabins, breathable air, stable temperatures. Unfortunately, this is also the perfect environment for bacteria and viruses to thrive. And here's where things get interesting. Astronauts aren't just battling the challenges of spaceflight, they're also battling stress, launches, zero gravity, artificial habitats. All these stresses weaken the immune system. NASA studies have shown that dormant viruses in astronauts can reactivate during missions. Herpes viruses, which include cold sores, chickenpox, shingles, and more, have been found shedding in astronaut saliva and urine. In simple terms, stress allowed these viruses to wake up and attempt to spread. Now, this doesn't mean the crew becomes dangerously ill. The International Space Station has strong air filtration systems to limit transmission, but the risk grows with mission length. A short stay in orbit might not be a problem. A journey to Mars, lasting months or even years, could be a different story. One possible solution is vaccination, but only some herpes viruses like chickenpox have vaccines available today. Others remain beyond our reach. This means that in space, humans carry with them not only the potential for exploration, but also the hidden risk of their own microbiome. So far, we've considered forward contamination life from Earth spreading outward. But what about the reverse? Could alien microbes contaminate Earth? A scenario known as back contamination. Asteroids and comets have already been studied up close. ESA's Rosetta mission, for example, discovered complex organic compounds on a comet's surface, including amino acids and nucleic acids, the very building blocks of DNA. Does this mean comets host life? Not necessarily. There is still a huge leap between having organic molecules and forming even the simplest cell. After all, comets lack atmospheres, liquid water, and protection from solar radiation, all things that life as we know it depends on. But let's imagine, suppose some form of microbial life did exist on a comet or asteroid. Suppose a fragment reached Earth, survived the fiery plunge through the atmosphere, and landed intact. Could it infect us? The odds are extremely slim. Viruses are specialists. They evolve to infect specific hosts. An alien virus would likely be built differently, perhaps even using a system entirely unlike DNA or RNA. It might be as incompatible with us as a key designed for a completely different lock. Still, scientists remain cautious. If we bring samples back from Mars, for instance, NASA protocols demand strict quarantine and analysis before release. Even if the risk is low, it isn't dismissed outright. Some researchers even argue that contamination has already happened naturally. Meteor impacts on Mars and Earth have exchanged rocks for millions of years. Perhaps microscopic hitchhikers travelled with them. If so, the boundary between Earth life and alien life may be blurrier than we think. So where does this leave us? On one hand, the probability of either forward or back contamination seems small. Sterilization processes work, viruses rarely survive. Space travel and alien microbes, if they exist, may be biologically incompatible with us. On the other hand, probabilities are not certainties. The fact that agencies like NASA build strict safety protocols shows us something important. They aren't ignoring the possibility. Some scientists go even further, suggesting that Earth and Mars have been swapping microbes naturally through meteorites for eons. If that's true, then perhaps we are already part of a much larger cosmic ecosystem. So can viruses survive in space? Not for long on their own. Could human missions accidentally carry life to other worlds? The chances are small but real. Could alien microbes infect us? Highly unlikely, but not impossible. In the end, what this really shows us is how fragile yet resilient life can be. Even the tiniest organisms, often invisible to the naked eye, have the power to shape worlds. And so, as we prepare to journey further into the solar system and beyond, the questions we ask about viruses and microbes aren't just about health or contamination. They remind us of something deeper, that life, wherever it appears, may be the most powerful force in the universe. What do you think? Could panspermia already be happening with Earth and other worlds, quietly trading life across space? If you enjoyed this exploration, make sure to subscribe so you won't miss the next journey with us here on Cosmic Compass. Until then, stay curious and keep looking up. Thanks for joining us on this exploration. If you enjoyed travelling through science and space with us, don't forget to subscribe and ring the bell so you'll never miss our next journey. Your thoughts matter too. Share your ideas in the comments below. Could life already be spreading between planets without us even knowing? Until next time, keep wondering, keep exploring, and let's continue navigating the cosmos together right here on Cosmic Compass.